Okay, and so this is an example. You're going to have to factor this one. If it bugs you to look at it that way, how many of you, does it bug anybody to see it that way? Like, it would be easier for you to factor it if it was 2x squared minus, or 2a squared minus a minus 1. You could, it's easier to look at this. Okay, so if you're going to factor it, notice it's a quadratic. It has a square on it, right? Right here. So if I'm going to factor it, it's going to, do something like this. If I've got 2 sine squared, I know that I'm going to have a 2 sine x times a sine x, because there's got to be a sine x in each one of those parentheses, right? Now, negative 1 is just 1 and negative 1. How could I end up with a negative sign, though? Where would I put the negative 1 and where would I put the positive 1? If I put it here, it would be positive. So what if I take that and that? Let's do it that way. Does that work? Because you'd have minus 2 sine x plus sine x, right? So that would be a negative sine x. They give us our middle term. So to start these out, when you see these squares on them like this in 3 terms, you're going to factor it. And if you could substitute a, like let sine x be a and say it was 2a squared minus a minus 1 if you need to. That's something you can do. A lot of people do that on these. Once you get it factored, what do you think you're going to do to solve it? What do you do when you factor and you set something equal to 0? How do you solve that? The video. We find our solutions by setting each factor equal to 0. So, for instance, we take the first one. 2 sine x plus 1 equals 0. We set it equal to 0, and then to get the other solution, we set the second one equal to 0, right? Well, oops, ran off the iPad there. Let's do this one on the right since I kind of ran off the iPad and since it'll be easier. If I want to solve and find out what x is, couldn't I add 1 to both sides, right? And I get sine x is 1. Where do you think I'm going to look to find a sine value of 1? If you look on the board at the little chart we made, we don't have a sine value of 1 up there. So what's our other place we go to look for values since we're not supposed to be using our calculator? Yep, unit circle. So let's come up here. So we're looking for the thing that has a y value of 1. Wouldn't that be right here at 0, 1? Because the y value, and then what is that? That's, we'll say it in radians, pi halves, right? Yeah, 90 degrees pi halves, okay. So we know it's x is pi halves. There is not another value on the whole unit circle that has a y of 1. So that's our only solution here. Later we will be looking, even if we were looking for more solutions, that one wouldn't have one. All right, so now coming to the one on the right, how would I solve it? Basically what I'm trying to do is to get if you notice, I'm getting the trig function by itself, aren't I? And then I'm thinking about what angle has that value on the right-hand side. So what would I do with 2 sine x plus 1 equals 0?
First, I would just take away the 1
yeah.
first.
Mm-hmm.
And then divide by 2.
Mm-hmm. Good. Okay, so it would be 2 sine x equals negative 1. Then you divide by 2, just like James said. We get sine x is negative 1/2. Okay, so if we're thinking about what angle that could be, it would be, and again, they're telling you the answers in the book. I'm just showing you how to get the answers because you're supposed to verify it. So really you're supposed to do what we're doing here and then say, that's there it is. Let me go ahead and write this little memory device here because we're going to use that a lot in this section. This is one of your go-to things in this section. You're going to always want to write that. All students take calculus. We know that if the sine value were 1/2, we're talking about a 30-degree angle. But this is negative 1/2, so we're just talking about an angle. We're talking about the reference angle of 30 degrees, but we want to put it in the quadrants where sine would be negative. Sine's positive in the first quadrant because everything is in the first quadrant. Sine's positive over here, so I don't want that quadrant. That means my answers, 2 of them, are going to be here and here because those are the 2 quadrants where sine's negative, right? So it's a 30-degree reference angle, or maybe we'll translate it over to radians in a minute. How about we think in degrees, translate to radians at the end? Well, I don't know. We could do it either way. if it's, let's think in radians maybe. If I'm looking at this one in the third quadrant here, it would be pi, and then 30 degrees is pi over 6, right? And haven't I gone 30 degrees or pi over 6 radians past pi? Because 180 degrees is pi. So that would be what, 5 pi over 6? No, wait a minute. No, because I would need a common denominator of 6, so it would be 7 pi over 6, wouldn't it? Is that right? That look right to y'all now?
You would think so.
You would think so. Pi plus pi over 6 would be 7 pi over 6. Now the other one's over here. It's 30 degrees shy of 2 pi, or it's pi. I could say it would be the whole 2 pi, except I need to subtract 30 degrees out of it. So I could say 2 pi, 30 degrees is pi over 6. If I get a common denominator, isn't that going to be 2 pi would turn into 12 over 6 pi, right? 12 over 6 pi minus 1 pi over 6 would be 11 pi over 6, right? You keep the denominator as you subtract on the bottom, and you just subtract 12 pi minus 1 pi is 11 pi. So it would be 11 pi over 6. Let me write it over here because I'm running out of room there. So here were our two answers for that one. They're going to tell you, like if you look at numbers 7, 9, and 11, they're going to say find all the solutions of the equation in the interval 0 to 360 degrees. That just means they want you to do what we've been doing here, is find all the ones in one trip around the unit circle. But if you think about when you graph sine and cosine and tangent, aren't they go on forever, don't they? So we're going to have to learn how to describe things that go on forever, all the solutions. So why don't let me do, really, if you can do what we just did, 7 through 15 is pretty easy. Let's move on to where we're trying to find all the solutions. Let's look at 61. Not all of them are this weird either, so I'm going to... Cosine of x over 4 is 0. Okay, now this is kind of require a little bit of thinking here. Where do we have an x value of 0 on the unit circle? Because we know that 0's got to come from the unit circle.
Oh, no.
I'm just going to write in the points. Right here's 1. This one was 0, 1, so that's not it. But over here we also have 0, negative 1, right? And then here we have 0. Oops.
It's negative 1, 0. Right?
Yes, I messed up. I always do that. 0, negative 1. We want the x value to be 0. So where's the x value equal to 0? Be here, wouldn't it? And here? Because cosine is your x-coordinate on the unit circle. So now, here's what you kind of got to do here. This doesn't say cosine x equals 0, does it? It says cosine x over 4 equals 0. We know the angle is either pi halves, is one of them, and the other one of them is 3 pi over 2. So I'm going to kind of split this into two parts here. So what I'm going to have to do in order to figure out what x is I'm going to have to set x over 4, this part right here, because it's kind of funky, isn't it? I'm going to have to set it equal to pi halves. So what would I do? Yes. So to solve for x, wouldn't you just multiply both sides by 4? Okay, so that would give you 4 pi over 2, which is 2 pi. Okay? Let's go over to this other one. I also know this is a solution for cosine of an angle is 0, but it's x over 4 in this case that gives us the 3 pi over 2. So if I want to solve for x, multiply both sides by 4, x equal, let me go ahead and reduce first. Well, it'd be 12 pi over 2, but I could reduce, first. Either way, I end up with 6 pi, right? So I get 6 pi and I get 2 pi. Let's look at 63, because I think trying to figure them out, and when I was learning them, I would go, what? What do I do here? All right, so what's that telling me? Yes, I do need to solve the problem. What am I looking for on the unit circle that I'm drawing right now? A positive 1 in the x value, right. And then, no, not in the x value. Sorry, I just repeated what you said and I didn't think. Isn't sine on the unit circle the y value, right? Oh, y'all are so alive. I know, your brains are still asleep.
I just zone out way too easily.
Okay, so you can stand up if you need to wake up. You can always stand up, move around, stretch while you're thinking about it. I don't care, whatever it takes. Just don't, you might want, oh, no, do that. Aren't I looking for a y value of 1? Where do I have a y value of 1 on the unit circle?
You have it at pi over 2.
Pi over 2. So I know that pi over 2 is the angle that gives me that sine value of 1. So what I'm going to do is say, well, 4x has to be equal to pi over 2, okay? See what this is the same as the last one, just wanted to show you another one like this. So if I want to solve for x this time, I'm going to multiply both sides by a 4th, aren't I, to get x by itself? Okay. So that would give me x, sorry, Caleb, I'm writing in red again, x equals pi, oh, yellow, okay, pi over 8 would be my solution. Now, the instructions here give us a hint. They say solve the multiple angle equation. So x over 8 is right here. Let's see, all students take calculus. Where else, if I have pi 8s here, where else would I get a pi 8 reference angle and it needs to be positive? Where else is sine positive? It's okay, we just found the one on all. Yeah, we found the one in section 1. Won't sine also, but yeah, in section 2, sine's also positive over there. So over here, sine is also positive. So that reference angle over here would also work. So if you look at that, couldn't I say that's pi minus pi over 8? Thank you, Caleb. I feel like I'm like hanging out here by myself sometimes, but I know y'all are just sleepy. So if it would be pi, let me just come over here. It's pi minus pi over 8 that would put me with that reference angle. If I make a common denominator, I'll call pi 8 pi over 8. Just get a common denominator of 8. So what would that give me? Elizabeth, what would that give me?
I think is a
Well, we're just trying to find the reference angle, and we just have found a common denominator. We said one of the reference angles is pi minus pi over 8. It's this green angle up here that I'm kind of wiggling the cursor around.
It would be 7 pi over 8.
Yeah, 7 pi over 8. So there's my other solution. Now, if I want to talk about all the solutions in the whole universe, I could add 2 pi n to both of these. Because isn't 2 pi another trip around the unit circle?
Yes.
So I can, as long as I'm making whole trips around the unit circle, I would get more values. On this one, they just said solve. So I'd really need to include this plus 2 pi n on my solution because they just said solve. They didn't, a lot of these problems are restricting it to one trip around the unit circle. When they say like 0 to 2 pi, if they just want you to talk about the values in one trip around the unit circle, or maybe it'll say 0 to 360, which they're pretty much sticking to radians here. But if they just say solve it, you're supposed to tell all the solutions, not just the ones in the first trip around.